For your retake work so far, you should have this formula sheet filled out. I would use it on this assignment and on the retake. Okay, and I would probably do the practice test again that was in the Thursday folder for April 16th. But I'll go through the questions here. You should have already made one attempt before looking at these answers, and you can see how you're doing on these. Now, like I said, the practice test is a good thing to go over again because this doesn't have every type of question you will see. This is going through kind of the big ideas again. So, question one, we have ourselves a triangle. Let me pull up a whiteboard here. It just says find the area. So maybe this is even work in your head here, but for a triangle, we have 1/2 the base times the height, or base times height over 2. So on the bottom here, we have a 4. That's going to be our base. The height this time is 5. So we have 1/2 of 4 times 5. 4 times 5 is 20. 1/2 of 20, we have 10 meters squared. So that's number 1. Number 2 is parallelogram, so that's base times height. So now we're on area equals base times height. Well, the base is 9. All right, the base isn't always the bottom, but whatever the right angle is touching is the base. So the right angle is touching this, so technically this top side is the base. Well, that if the bottom is 9, the top is 9. So we have 9 for a base. We have a height of 10. 9 times 10 is 90. This one we don't have to cut in half because it's not a square. I'm sorry, not a triangle. Okay. Question 3. These ones, don't let the dashed lines over here or over here fool you. We don't need to know how long this is. This is back to triangle. So 1/2 base times height again. We don't have to worry about, like I said, how long that dashed line is. The base is what the right angle would be touching, which would be the bottom side here. So the base is 10. The height is that dashed line then, which is 6. So this is 1/2 of 60 or 30. Okay, and this one is square feet again. Okay. Question 4. Well, maybe I should be typing these in as well. So that one's 30. Okay. Question 4, back to parallelogram. We're kind of going back and forth a little bit. But we have base times height. That one's pretty straightforward then. The base is the bottom, which is 16. The height is 10. We have 160 square feet for our answer. Okay. Let's see. This one, we have a trapezoid now. So now we're on number 5. The formula for trapezoid is 1/2 the height times the bases added together. All right, for this one, we do have most of what we need. We don't know the height yet. Okay, oops. We don't know the height yet. We do know one of the bases. Let's say the top base is base 1. That's 11. We know base 2, technically. We have a 6 and a 15. If we add those two together, the other base is 21. Okay, so far we have 1/2. I'm going to leave the height parentheses empty for now. We have 11 plus 21 for the bases added together. Okay, so now we got to get that height. All right, here's what we have. This triangle over here is a 30, 60, 90. So what we know is that this is 6 and this is 60. All right, so we know that what we have here is the short leg. The height, what we're looking for, is the long leg. Okay, remember with 30, 60, 90s, to get from short leg to long leg, we multiply by square root of 3. So the height has to be 6, since 6 was the short leg, times the square root of 3. That's what h is. So I'll put that in here. Okay. All right, so then we're ready to answer. So we have 1/2 times 6 square root of 3 times 11 plus 21 being 32. Okay, so if you do 1/2 times the 6, that's 3, and then 3 times 32 is 96. So it looks like we have an answer bank for this one. 96 square root of 3 is the same as all of this stuff multiplied up. So I would choose 96 square root of 3 for my answer. Well, you know what I mean. I'll just type it in. Okay. All right. So, and now we're ready to move on to number 6. So, number 6 is a rhombus. I can tell because there's the same amount of tick marks on every side. So for a rhombus or kite, we have the same area, 1/2, diagonal 1, diagonal 2. Okay, so as long as I know what the diagonals are, I can solve this problem pretty quickly. So let's say diagonal 1 is this one coming through. So if this piece is 10 from the corner to the middle, this piece is also 10, meaning 10 plus 10 is one of my diagonals, or 20. Okay, over here we have a 12.8 and another 12.8. If you add those together, you end up with 25.6. And then we're ready to go. We can get into the formula here. So we have 1/2 times the diagonal 1, which is 20, times diagonal 2, which is 25.6. 1/2 and 20 is kind of like having 10. 10 times 25.6. This one has an answer of 256 square feet. Okay, so 256 goes there. Question 7. Now we have a kite, which is actually the same formula. So again, as long as I know what the diagonals are equal to, I can solve this problem. So let's say diagonal 1 is this corner to this corner again. If this is 6.5 and this is 6.5, I can add those together. I end up getting 13. All right, this diagonal is 10 and 8 added together. So what we have here is 1/2 times 13 times 18. Okay, that's kind of like doing 9 times 13, or you can just go to the calculator for all of it. We have 117 square centimeters for our answer. Okay, all right, trapezoid word problems. Okay, the word problem for number 8 says a trapezoid has a height of 6. So remember, this is our formula for trapezoid. I'm just going to fill in what they tell me about the trapezoid. So we have 1/2, the height is 6, they told me that. Okay, it has a height of 6. Okay, the area of the trapezoid is 60 square meters. That's capital A, so I'm going to put that over here. One base is twice the height. Well, the height is 6, so one of the bases is 6 times 2, which is 12. And then they want what is the length of the other base. So I don't know what B2 is yet. So there's one like this on the test that you saw. It's also on the practice test. But we can solve this for B2. All right. So we want to move everything away. We want to start. Let's see. I'm just going to do the 1/2 times 6 here. Call that 3. Then it's going to be 2 steps here. If I divide by 3, we have 20 equal to 12 plus B2. And if I subtract 12 from both sides, I have 8 equal to B2. So 8 meters must be how long that other base is. Okay. All right. Regular hexagons, or regular polygons in general. Okay. 1/2 ASN. See what they gave us, see what we know, and what we still need to figure out. Okay. They gave us 18 here, but that's not called an apothem. That's not A. That is called the radius. So they gave us the radius of a hexagon. So I don't know A or S. I know that N is 6. That's how many sides there are. Okay, so let's take a look at what this triangle would look like. Okay, right there. So if I draw that triangle, I know that this piece is 18. Okay, I'm going to do that one more time. There we go. So I can kind of draw the apothem down the middle. That's what I want to figure out. Okay, I want to figure out A and I want to figure out S. Okay, so I'm going to put an X right here for now. X is going to be half as long as the side. So since it's a hexagon, there are 6 sides. So the angle up top here is 360 divided by 6. That gives you 60, but then A is going to cut that 60 in half so that this is a 30. So if I'm looking at this triangle now, I have a 30, 60, 90. So here's the hypotenuse, here's the short leg, here's the long leg. Okay. To get from the hypotenuse to the short leg, we divide by 2. So if 18 is the hypotenuse, 9 is x. Well, that means this piece is also 9. 9 plus 9 gives me the side length then, which is 18. Okay, A is then this piece times square root of 3, the short leg times square root of 3, or A is 9 times square root of 3. Okay, so then I'm ready, since I have all three pieces of information, I'm ready to solve the problem. So I have 1/2 times 9 square root of 3 times 18 times 6. Now this said to the nearest tenth, so we would just go to the calculator and we would get our answer. So if you plug all that in, we get 841.77. Well, that's going to round up to 841.8 square yards. Okay, so that would be our answer for that one. So if you don't know everything for a regular hexagon, you got to use special right triangles somehow. Okay, let's go and do one where we do know everything. What is the area of a regular decagon with an apothem of 6.3 and a side length of 8? So A is the apothem, all right, and they told me what that was. They said it was 6.3. A side length is 8. A decagon has 10 sides. So we're ready to go right to the calculator. 1/2 times 6.3 times 8 times 10 it should be 252. So that time we don't have to round. It's that number exactly. So if you know everything, you're ready to go right to the formula. Okay. All right. The rest of it is 10/4, which some people struggled with on the test. All right. Remember, we either have a to b or a squared to b squared. A to b was for scale factor or perimeter. This is for area. Okay. So scale factor or perimeter is a to b. A squared to b squared is area. Okay, so this one wants the ratio of perimeters and areas from first figure to second figure. So there's the order we're going in. Okay, well, the ratio of perimeters looks like I have one side length that's 3 and another that's 6. So that would be my A to B, except for I need to simplify that. I want to simplify it down by dividing them both by 3, and so I get 1 to 2. So A to B is 1 to 2. Okay, to get the ratio of areas, then I take that and I square them. So 1 squared and 2 squared. So that's 1 to 4. That would be my ratio of areas. Okay, and that's on your formula sheet as well. If it's not, then get it in there. Scale factor and perimeters are the same thing. A to B, A to B. This one's A squared to B squared. Okay. Let's see, number 12. If the ratio of areas is of two regular hexagon is 8 to 50, then what is the ratio of the perimeters? Same thing as asking for the scale factor. So this is a ratio of areas. Okay, so I know that 8 to 50, that is currently A squared to B squared. Okay, so what I need to do to get the ratio of perimeters is I need to turn that into A to B. All right, so the way I can get A from A squared is taking the square root. Before I do that, I notice that I can simplify. 8 and 50 are both even. I can divide them both by 2, and now it's 4 to 25. Now that's helpful because I'm about to take the square roots, and now those are both perfect squares. Okay, so now the square root of 4 is 2. And the square root of 25 is 5. So 2 to 5 is the ratio of the perimeters then. Okay. And then the ones with proportions. So last one here. The ones with proportions, what you're trying to do is get the ratio in the proper terms. Usually it's ratio of areas on these problems. And then writing a proportion that we can cross multiply. So the ratio of perimeters of two similar triangles is 1 to 3. So that means 1 to 3 is currently A to B. So then what they give us next, it says the area of the larger triangle is 27. So since they're talking about areas and they want us to find an area, I need to take this 1 to 3 and I need to convert it into a squared to b squared. So that would be 1 squared to 3 squared, which is 1 to 9. So this is the ratio I need to use in a proportion. Okay, since I'm talking areas, I need to make sure I'm talking a squared to b squared. So then the final thing we got to make sure we get right, the area of the larger triangle is 27. So since 9 is the bigger number, I'm going to put 27 down here since it said larger triangle. If it would have said the smaller triangle, I would have put the 27 up top. So then I got an x here, and I'm ready to cross multiply and solve. So 1 times 27 is 27. 9 times x is 9x. Divide by 9. Our answer then is 3. If the, there we go. If we have a triangle of 27 with a ratio of the perimeters of 1 to 3, that means if the larger triangle has sides 3 times as long, it has an area 9 times as long, so 27 divided by 9 gives us that answer of 3. Okay, feel free to watch again. Like I said, I would recommend doing the practice test again as well in preparation for that retake.